This is from technical debt to technical investment. Um, again, we'll have some time for discussion at the end, but we're kind of going to walk through our approach at Nerd Noir and how we, kind of tackle these things. This is a problem that we are really familiar with. This is a problem that, often bridges product and business and technology and engineering. This is kind of shines a light on some of the problems between those two groups or, sometimes silos, right? And just one word, if you do post about this on social media, we'd love it if you'd use the hashtag technical investment, just so we can kind of see what people are saying and like and amplify your message as well. So without further ado, let's get into it. I am Dave Larrabee. I've been developing software for 30 years now. Started writing programs for cash at the tender age of 19, so you can do the math. My background is in product engineering and leadership. And at Nerd Noir, we work with companies of various sizes from extremely incomprehensibly large and huge, gargantuan, to, kind of smaller scale up startups and stuff like that. So a lot of different things. We work across a lot of different industries and get to one of the benefits is you get to kind of see what's going on there. I would say what qualifies me to talk about technical debt? Well, I'd say the first 5 to 8 years of my career, I was a prolific creator of technical debt. And so I know a thing or two because I've done a thing or two. Uh, and then after that, kind of when I had that realization and started doing things like extreme programming and test-driven development, I really understood this as a kind of core problem, and that problem kept coming up. So I've written about it a bunch, I've talked about it a bunch, and I really credit this to kind of keeping my career interesting over the last couple decades. So a little bit about me. And you want to say hi?
Sure. Ann Snyder, 25 years in tech. I've worked as both a developer and a product manager and a consultant. And I think, what I want to bring to the table today in our conversation is really, hey, product managers, what does technical debt have to do with us? Why should we care? And how can we make things better for the good of our product? Because I think sometimes in the industry, people are led to believe, hey, that's an engineering problem. Let engineering fix it. And sometimes engineers think, hey, that's an engineering problem. I don't have to explain it to the PM. And we're going to dig into those myths today.
Yeah, great. So let's jump right into it. I love models. Like I'm a model driven, domain driven design type person. So I kind of collect all these models. I realize that, they're good for some things. They're good for understanding stuff like that. So I don't over index on it. But I want to kind of start our conversation out today with a bit of a model. So this is Martin Fowler's technical debt quadrant model, and I'll kind of walk you through this a little bit. In the top right, you've got this is like the OG what technical debt was supposed to be kind of thing, which was a trade-off, right? This is Ward Cunningham's technical debt metaphor, where we're going to incur some debt as a trade-off so that we can release our product and learn about that. Like learn about things like our how deployment works, learn about, I don't know, do customers want or need or even care about this thing, right? And so the idea was it would be a good thing to incur a little bit of debt and not have a perfect model of in our software to learn that stuff. With the idea that once we learned about that, we take that learning and kind of bake that into the perfection of our model, right? And that's what tech debt means. But when you hear executives and when you hear actually 90% of people talk about tech debt, that's not what they mean. They mean stuff that kind of slows you down. They mean anything that is costly or scary or hard to change. That's kind of what the industry has turned tech debt into. And rather than be pedantic, I want to kind of embrace that definition, right? It's tech. Tech is holding us back. It's holding us back from customer value, delivering customer value, business value, that kind of stuff. Or, as a developer, it's creating a kind of joylessness and frustration in what I'm trying to work on, right? So the other quadrants we have, I'll go down here. So you have deliberate up here. This is like we intentionally made that choice, and inadvertent. It's like, oh, that's an accidental complexity thing. On the right, we've got prudent, which is, sensible, wise, intentional. On the left, we've got reckless. It's just like, whatever, let's just go. On On the bottom right, we've got prudent debt. And this is stuff that's like, hey, we started out with this set of knowledge and understanding. We went down that path and we solved for the problem that we thought we knew. And later down the line, something happened that changed the problem space, right? Market conditions. Oh, we're scaling. I think like Twitter back in the day when it was usable, was a Rails application. It was, trying to do millions of messages and it should have been written in C, right? So they knew Rails, they went and did it, they made it successful, they got to a, product market fit where people wanted to use this thing, but then it started to kind of fold because of performance. That happens all the time, by the way. I think it's kind of avoidable. It's like learning progresses with debt, right? So it's one kind of way to think about it. Over here in the bottom left quadrant, you've got, we just don't know what good design is, right? We don't have the tools. This is like, think back to, you know, Proto Dave, like back in the 90s and early aughts when I'm learning to write software and I'm just writing classic ASP pages with embedded SQL and just going as fast as running with multiple scissors as, and just, I didn't know any better, right? I didn't have a mentor. I didn't have, didn't do the reading, didn't have the experience. And this is, where a lot of people new to the industry kind of tend to start. And then up here in the top left, we have probably the most insidious form. This is kind of your institutional form of technical debt. This is where it's like speed over quality, delivery, 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 push out things, feature factories, stuff like that, right? So this is where there's some intentional choice to prioritize delivery at the expense of any kind of qualities or systemilities or things like that.
Paano mo natinig ata?
Dave, this is one that really stands out to me too from the product manager seat, because I think sometimes that technical debt that this quadrant is causing is really a symptom of poor product management or the inability to articulate and map a strategy to execution.
Yes. So great tee up. And we can look at this quadrant and we can start thinking about strategies. Like if we're going to manage this debt, or if we're going to get it under more toward the top right quadrant where it's an intentional trade-off, what do we do? Right. And so I'll kind of start there. Ideally, it is a managed trade-off, right? We incur debt in favor of learning, right? If it's not there, maybe in the bottom right, the strategy is more like how do we achieve a balance or negotiate the right proportion of balance continuously, like new functionality to technical investments. How do we kind of balance those things? And that's not a real easy thing because it's a social problem, right? And in the bottom left quadrant, we have things like upskilling or collaborative engineering. How do we kind of bring a group together? How do we bring like senior engineers or staff plus engineers into the mix to kind of help raise the skill level of all the engineers that are newer, right, to a code base? And you could be a very experienced engineer and throw it into a very complicated code base, and all of a sudden, in that context, you're a junior engineer. So it almost has nothing to do with time. It has everything to do with, the combination of your knowledge and what you're asked to work on. And then the top left, we're kind of, Anne was getting at, is like radical change, right? So when we have a systemic kind of, conditions that incur debt rapidly to the point of crisis, we might have to do something radical. Kaikaku, one of my favorite Japanese words, just because it's hilarious, right? Radical change, right? It's kind of the opposite of Kaizen, which is a kind of continuous, gradual seeking of perfection, right? But this is where you get things like modernizations, I guess is what we call new big rewrites, right? This is where you get things like transformation. This is where, and everyone really enjoys that stuff, right? So few kind of strategies. One way to kind of think about this is another model is the kind of cost of change curve, right? So get this out of the way, but essentially what you have is in the top left quadrant, you get this goldenrod, yellowish kind of spiking. And, on the left, on the y-axis, we have costs. On the x-axis, we have time, like kind of in the year scale, right? But your changes might go really quickly if you're just hucking code in. But at a certain point, if you're not thinking strategically and adding the necessary tests and documentation and supporting artifacts and practices and stuff like that, things are going to get harder and harder to change, right? And to where they approach this kind of zone of crisis, right? Which is this area here. And this is where tends to be like too costly to change, too hard to change. This is where you get into expensive rewrites and incurring all the risks associated with that, right? It's
And that's
another.
where we start to hear things from leadership or maybe from product management. I can't get any features. Engineering is slowing down. Engineering is failing. But it's really, we as an organization and product group, we failed to invest in the needs of our tech for so long that now we literally are paralyzed.
Yep. Yep. Now, I mean, a better look is like this, and this is kind of the classic XP, extreme programming kind of mode where we're doing refactoring and test-driven development. It's emergent design, and our learning kind of keeps pace with our, the structure of our programs and stuff like that. And that's ideal. It's a little more expensive because of the lift in learning in the beginning, but it tends to give you more level cost of change as time goes on. Just want to give credit where credit's due. I have no idea who made this model. I got it off the C2 wiki, another Ward Cunningham innovation. Ward's invented like, three of the 10 things that I think are cool in software development. So I'll shout Ward out again. All right. So, one of the kind of common root causes, right, for this hockey stick cost of change is feature factories. Why are feature factories bad, Ann?
Uh, why are feature factories bad? I mean, gosh, I don't even know where to start. Maybe let's start with the Standish report. It says year after year after year that the majority of the features we build are never used. A lot of times as PMs or salespeople, we think we can beat the competition by having more features, by having more checks on the product marketing material. But it doesn't work. You've got to have the right features, and every feature that we build that no one uses, we still have to pay for. And I'm not talking about the pay of build. That's the cheap part. I'm talking about the pay of maintenance, support, tech debt, code base bloat. We need to be building more of the right thing, less of the wrong thing. And if a feature isn't getting used, we need to pull it from the product.
Amen, sister. All right. So feature factory is bad. I mean, I'm just saying this is one of those things that leads to this high cost of change if we're not thinking about qualities and investing in things like system outcomes and availability and performance and security and things like that. This is, if you, yeah, it's a problem. One question I have is why do we call it tech debt anymore? If it's taken on this new meaning, if we call it tech debt, is that not pointing a finger at one group that is just one of many that are conspiring to kind of create this? And I think they are. I like this quote from Mike Fisher, former CTO at Etsy. I will be sharing these slides. It's a Miro board, but there's all kinds of links in here too. So if you want to explore more, a couple links to Mike's original post. Super smart dude, great Substack, recommend it. And there's a podcast with one of our partners, DX. They interviewed him, but he makes a really interesting point as we kind of push out our products, even if we don't think of them as products, as we kind of push out our products. What are the parties that kind of, one of the trade-offs of that is we're going to incur debt, and it's not just an engineering thing, right? I'd argue maybe product debt shifts the um, pointing to just a different department. So I like where this is headed, but I think there's maybe a better way to kind of think about this stuff, right?
And I kind of like the term product debt, or it's better than tech debt. But Dave, we can't think of product as a department there. We have to think of product as the thing that we build that impacts people.
Copy that. Gotcha. So, what I would like to do is kind of shift the thinking from just debt entirely. I'm taking issue with that word, debt. It's not a good thing generally. I mean, I have a mortgage, and so I understand that there are trade-offs, and having that gives me more buying power than just cash, right? That's great. But in general, there is a kind of a stigma assigned to that. It can promote blame. I think more than anything, debt feels like kind of this past decisions, sunk cost fallacy thing, right? Where we
Yeah,
have,
I think it also implies that it's something that can be paid off and will be done. Your mortgage, Dave, one day you're going to write the last check and it's over. And most debt can be paid off unless you're the United States government or some trash like that. But tech debt, it isn't like that. There's no done.
yeah, yeah. So I'd like to shift to investment. I'd like to kind of say, what are we going to do about this? What are our future returns? And, if there's any people that do investments on the call, I mean, lately it's been better, right? But for a couple years prior to recent times, it's been absolute shit. So I feel like you have to kind of, think of an investment as kind of more of an educated bet, right? As kind of something where you're going to do something and hold it, right? And kind of see if you get a return on it. Also, we're starting to speak in, kind of terms that I think speak to leadership and speak to some of the parties and stakeholders that we have to kind of convince, right? It's like, if we do this, we get this return. We think we'll get this return. And I really like it because it starts changing the conversation to what have we done and kind of, guilt and blame to, okay, cool, here's where we are. What are we going to do about it? Right? You know, okay. So technical investment. Let's dig into it. So we have a couple scenarios we want to share. The first scenario, and there are different levels too. So I just kind of want to illustrate like this can happen like top down, this can happen bottom up. But the first scenario is a team, and these are real stories. The names have been changed to protect the innocent, and faces have been blurred and stuff like that. But it's really about a team stacked with newer engineers. So a brand new team, and again, these engineers may have years of experience, but they're new to a very complex system. This system is heavily coupled, and the design choices that were established were, really like database level integration and all kinds of issues that, as the system kind of gets bigger, get more and more unwieldy. So it's a re-architecture is one way to think about it. And what this team wanted to do is start extracting kind of services from this. And one of the services they wanted to extract was one that was impacted by regulation changes, right? So the regulation changes that were baked into the software had changed. So in this case, if we go back to the quadrant, um, arguably this is where that tech debt is, or technical investment needs to be made, right? It's around upskilling, understanding how do we do this, understanding how does this complicated architecture work. So we found a target, right? What you're seeing here is a tool called NDepend. This is on the fancier spectrum side of the spectrum of tooling. We'll show you one that's a little bit more of a lo-fi tool in a minute. But what you're seeing here is a kind of static analysis of a code base where the larger squares are classes, right? So this is a .NET code base, NDepend's a .NET tool. And the size indicates lines of code. So the size of the overall larger boxes is lines of code. The smaller squares in those larger boxes are methods, right, on those classes. And the color indicates cyclomatic complexity. So if you're not familiar with that, all cyclomatic complexity is the number of potential paths through a method, right? So if it's red, there's lots of paths through it. If it's green, it's real simple, not a lot of conditionals, that kind of thing. And what we can find here is one big mamma jamma, right? In the middle here, we have this big class, kind of God class, with lots of a big method, in this case, an 8,000 line method, right? Very large. I mean, it's extremely stupidly large, right? So we discovered this and we said, okay, here's where we start to kind of pull things out, right? Let's start um, kind of pulling this out. So we ran this and, here's kind of an example of that. But here you can see now we've kind of pivoted down to the method level. That's the size of the box, lines of code in the method. The red is, or the color indicates the cyclomatic complexity, with red being bad. And we can kind of find a target, something to refactor, right? Next, we'll look at, here's the code, right? And so I'm not sharing the real code here. This is contrived, but this is kind of what went down. The code here is fairly simple, although, it takes some effort and strain to read it. And if we start multiplying this many, many times and we're trying to deliver a ticket or a story, we have to kind of read a bunch of these things. So our goal here would be to kind of reduce the complexity of this, make this easier to scan, make this easier to read. So that's exactly what we do, right? So kind of automated refactoring, no probably real surprise here. Here I'm doing an extract method. So I'm just kind of taking this set of statements, pulling this out into a method that is cohesive, that makes sense. So I'm going to go do that exactly right now. This method seems to be all around calculating an electronics discount. That's fine. We'll pull that out into a method, and we'll do that a couple more times. So not really shocking here. This is refactoring, but you need to know how to do that refactoring, right? The thing with this is, this is a lot easier to read, right? I don't need to go into those two methods at the bottom, calculate electronics discount, calculate expensive appliance discount, if I don't care about that. I can assume that's okay, or I can go into that, crack that open if I need to, right? So, I like this because one person's kind of minimal investment in reading and refactoring pays dividends for the next reader. So that may even be you down the line. And your understanding is reflected in the kind of code structure. And that's refactoring. No big surprise, like I said. But when we start looking at the metrics, what's happened, right? Our lines of code and our methods have gone down. Our complexity's gone down. And this kind of creates a profound realization that refactoring actually moves these kind of needles in the right direction. Now, I'm not saying lines of code or cyclomatic complexity are things you should over index on, but they kind of support the learning. And you do it some more and you get this, right? You do it some more and you get this, and you kind of get this high level visual of what refactoring does and this ability to kind of intersect, inject all kinds of interesting conversations.
Dave, would you see this as something where, a couple folks are pairing or, the team is kind of collaborating to learn from this process too?
Yeah, in this case, I mean, this is a real story. This was a couple sessions. This is like, a couple hours of working with the team. And we were kind of working in like an ensemble programming, software teaming, mob programming kind of context, right? So changing hands of the keyboard and going through trying to figure out the target. So yeah, I mean, I'll show you in a minute the kind of overall impact here in a minute, but the flow was like this. So we would target something that we wanted to refactor. We'd do the refactoring. We'd rerun the metrics and kind of see what happened. And then we would eventually commit. Inside there, we'd have all kinds of discussions, about what this was, what these metrics mean, how this kind of impacts things. Is this a better developer experience? That kind of stuff. So it's really not just refactoring, but it's like refactoring plus metrics plus the kind of learning that goes with it. Okay. So, what does this mean? Another metric we can look at is scale, SQALE, which has a very poetic meaning of software quality assessment based on lifecycle expectations. I can never remember it. I just call it scale. But really what it does is kind of attempts to measure technical debt. And I've done this by hand a bunch, and then I found this kind of metric, and they're pretty close, right? I think I don't fully trustworthy, but it's somewhat trustworthy, I would say. And it's, again, a metric for this. It's not something we'll look at rigorously, but, in just a couple of sessions, we were able to reduce technical debt in this module. We'll call it a module, it's assembly, by 2%, right? And that was the kind of profound realization and saying, hey, these little actions that I have start to conspire to make much bigger impacts. Yes, this is out of independent also.
Yeah, and
So
I really love this from the product manager seat because so often I think we agree to invest in technical debt, but we have no baseline, which you've taken here, and then we have no way of seeing progress. So in some ways, it just feels like you're kind of dumping money down a hole and hoping that something good happens at the end. I like where you're going here because you're doing something small. Or you're starting with a baseline, you're doing something small, you're measuring progress. If it works, we're going to do more of that. If it doesn't work, we'll do less of that.
yep. Carl, we'll get to that in a second. Very good question. So what from a product angle, right? But essentially the method is this, right? You kind of go through, you have a discovery phase, you use a tool, which could be a high fidelity tool like Endepend or something more lower fidelity. Um, you kind of work around and you find your target, right? And then once you say, okay, yes, and we use consensus to determine validity here, you frame what do you want to have happen. So the problem is they had a lot of large methods and types in their legacy code base. It slows development down. That in turn affects, product speed and ability, time to market and things like that. we said, hey, the team, wants to feel comfortable refactoring large methods and classes in the normal course of work. So as they're doing product delivery, they want to kind of slipstream this in and just make this part of the delivery process, cleaning things up, right? We looked at a couple metrics, lines of code in a method, cyclomatic complexity, scale, tech reduction as our kind of way of saying, are we making some progress? And those metrics may not mean a lot to product, but they certainly help the kind of learning and saying, hey, is this working? Is this worth doing? Should I keep going with it? And then lastly, we kind of go around this loop, and we went around this loop a bunch of times in a couple of hours. And we, do a little extract method, do some other refactorings, run the metrics, see what happens, and kind of have our discussion as a result. From a so what perspective, you know, um, and you want to go with product?
Yeah, some of this I kind of already spoke to, but I like the experimentation aspect of this. It doesn't feel so much like you're writing a blank check. I like some data. Now, Carl raised a good question of like, okay, 2%, that's real data, but so what? What are my ultimate outcomes? Now, there's probably an outcome that drove us to be pursuing this work anyway. Maybe we're getting a lot of bugs in one area. Maybe like Eddie's saying in the chat, maybe we're seeing a lot of customer churn and they're complaining about stability. Maybe we're trying to bring new engineers into the code base and they're making a lot of errors, which could indicate it's overly complex. So those are the outcomes I'm driving towards, and those are the lagging indicators. These things that you just showed, Dave, they show us some leading indicators that say, yeah, I'm on the way. And the other thing as a PM is I want to do this in small pieces. I don't want to tear that whole engine apart and lay it down on the floor of my garage because we don't have the time or the money to do that. There's always other priorities. But this allows us to do some work iteratively, maybe while we're in the area, maybe in the cracks in some time without having to tear the whole product apart.
Yeah. So from an engineering perspective, I mean, I think what you're doing here is skilling up. This is the upskilling the bottom left quadrant. You're taking away the need for permission to kind of do the right thing would be my favorite thing of this whole bit. But also just kind of continuously managing tech debt. It's not something where engineering is coming to product and saying we need to stop delivery of this new thing or we can't, we need to rewrite this. Like it isn't kind of an incremental approach. Right. But I think it's a skill issue. I think it really is something where you need to have a little bit of time to kind of build that skill, and then that skill can kind of go forward. So I didn't mess up the scenarios. I read the second scenario for the first scenario. Hopefully you got it. That was the team that was like trepidatious about changing things. Scenario 2 is extracting.
Hey, Dave, if you're willing to just take a moment on scenario 1, we got John Galvin. He's got his hand up. John, you want to throw something out? And you are on mute, dude.
Apologize, that was an accident. I didn't mean to do that.
Oh, okay. No worries. All right, never mind.
And Miro just reloaded. So there, 1 second. Let me pull my notes back up. Cool, cool, cool. All right. So think of a question, John, for the end. Okay. So this is the kind of one where we're extracting a big service. I messed up, copy paste error in speaker notes. It happens. And this is a very complicated backend software. Super, regulation really matters here. A lot of governing constraints, database level integration. So since I already read this mistakenly, we'll move on. I think arguably this is like had we known, we could have written it this way, right? This is very senior kind of competent engineers. They had outgrown their architecture. They had also had this external impact coming in from the outside, which tends to create tech debt, just like it like T-bones you a little bit. Like, hey, all of a sudden this thing's happening. Now you have tech debt where you didn't think you had. Your architecture is kind of broken. So in this case, we were looking to do some discovery, right? And think of that left side loop. And I said, hey, do you have any architecture diagrams I could look at? And I was presented with a PowerPoint that had very face melting, kind of flattened, super detailed, like hard to understand or track or just cognitive overload type diagrams. Very complicated, very hard to grok, very hard to kind of cut a path through that. So The other thing we kind of did with this, and these are lo-fi tools, right? So this is a top-down problem, lo-fi tools. We found that, there were some skill issues. This is a tool we like to use called Skill Matrix. On the top, you've got the various, capabilities or skills that a team needs to be productive. On the left, you've got the various, individuals and their role here. In this case, we had very clear gaps with like things like solution architecture, things like platform knowledge, things like business knowledge. And these things are all really, really important when we're talking about, you know, basically extracting a new kind of core domain into a service. What does this thing do? This really complicated business problem, really complicated architecture. And you've got a bunch of people that are new to this that are like, what's going on? So arguably, this is kind of both of these quadrants. So, this is where models fall down and they can help point you in the right direction, but they aren't going to make all of your wildest dreams come true or solve all of your problems. So in this case, it was a little mix, right? Some people had a lack of knowledge, and some people, and then of course there was just the conditions that needed this, that led to needing to change the software. Okay. Um, so what we kind of use here is saying, hey, let's do a collaborative session. Let's get together and let's start, mapping the architecture. This is a Simon Brown C4 model. Hopefully you can see this. C4 model is an approach to visualizing software architectures that its main innovation for me is it kind of breaks things down into levels and audiences. So at the top level, you have a system context or landscape diagram. These are like our big system, like our bespoke software integrates with our ERP this way, right? And we use third-party services here, right? So it's kind of a very high level, almost portfolio view of all the systems and how they interact. But double clicking into them, you can look at now the containers in that system. And this is kind of more like the runtime view. This is like where DevOps people or infrastructure architects or enterprise architects will really understand, sometimes engineers as well will really understand what's going on with this stuff. This would be like, we're delivering a, React bundle over an S3 container. It kind of gives you a sense of the tech stacks in use and the dependencies between them, right? And then clicking on one of these, and like in this case, this API application, we can zoom in and see what are the main kind of components. And this is more the logical view. This is how we can structure things with things like packages and modules and assemblies and or domain models and things like that. And so you can kind of zoom. And at this level, this is a very rubber hits the road, engineers, solution architects. This is very much like, yes, those people, but also kind of your infrastructure folks or your infrastructure architects. And at this level, it's kind of leadership, right? It's a free thing. You can go check it out. It's really easy to adopt. Highly recommend having, some set of diagrams here. There's a 4th code. I don't really bother with that. I kind of keep that ephemeral and we'll sketch it out or just look at the code. So we said, hey, let's start doing this. And the way I like to do this is using kind of that software teaming ensemble mob programming kind of model where, I will start drawing the system landscape and context diagram, right? And that's what you're seeing on the left of this image. And then I'll hand the marker off to someone on the team and be like, hey, why don't you crack one of these systems open and start drawing the containers? And then crack a container up and start drawing the components therein. So, we kind of rinse and repeat. And what's kind of interesting is if we draw laser eyes, pew, 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 and we look at the angle, laptop, and we see the eyes aren't angled at the laptop, this kind of collaborative approach is starting to get people interested, get people engaged, and get people asking questions. So it's not a multitasking kind of meeting where we're looking at some crazy PowerPoint. We're actually engaging in the architecture and kind of building a shared meaning of that.
Whoa, that's crazy. You mean we're going to stop coding for a minute and talk to each other?
Right, exactly. Right. So, yeah, I guess the feature factory is also an engineering problem as well, right? Maybe we could spend some more time doing this stuff. And then, what we're seeing here is a larger group socializing that. Now, it's a little hard to see. I'll zoom in here, but there's all kinds of like, potentially temporal coupling issues here. There's all kinds of dependencies. But what's more interesting to me is everyone's kind of reasoning about this and leaning forward and talking through this, and they're pointed at, a visual. We do this virtually as well as on-prem, obviously more these days, right? But everyone's kind of talking about it. And you have interesting parties. This is Mary. Mary's 30 plus year veteran, knows everything about this, one of the most complicated domains I've ever seen. And she's saying, nah, that's not quite right. That's not labeled quite right. You should call this, or that's, not really what's happening. We have technical coach, product coach kind of putting eyes on it. And then we have, of course, the broader team working through this, right? But it's sense making around architecture diagrams, right? Architecture diagrams ain't dead, especially if you kind of use them this way. Interestingly enough, what emerged as a practice, and this is nothing that we planned for, we just kind of rolled with it. But the team took their component diagram, which was where the changes where that services was going to be extracted, and they started saying, here's the path of data through that, right? That's kind of looks a little bit like a detective board, right? With the red string. But the data is going to travel through this, and each one of those waypoints is something that we need to extract. So what they're pulling out of this is a incremental backlog of changes to make this really risky, complicated thing happen. They're writing acceptance criteria on these. They're writing tests on these. They're talking about the order of operations and what needs to happen. All that done with product in the room. Now, this is platform product, so it's a little bit more of a techie kind of view on product. This is a back end system, but still all parties are kind of agreeing to this. And this is like how we'd use a user story map, right? We would kind of find slices or journeys through that story map. You can do this with architecture diagrams as well.
And I think this is something that's really important to the product people on the phone, because a lot of times as product managers and product owners, we struggle to write backlog artifacts for architectural work. And sometimes the engineers, you don't help us because you just tell us, hey, you don't need to know about that so that you don't have to deal with us writing acceptance tests and crazy stuff like that. But this really is showing in this picture this path, this journey, this increment. And now we can format our backlog items around that, and we can show and incrementally deliver working software.
Yep. So again, if we kind of come back to the skill matrix, I know I have a comment on that. I'll get around to those in a minute. Platform knowledge, business knowledge, and what was it? Solution architecture. If we take those, what we like to use the skill matrix for is just, to understand what's happening with a given team. But then after we kind of work with them, we want to see what happened. What was the result? Like, did they kind of level up on business knowledge, platform knowledge, solution architecture? In this case, yes. If you look at the legend, we use a really simple want it, got it, can teach, and leveled up. Want it means you want to increase. Maybe you have some knowledge, but you want to increase that knowledge. Got it means, you feel like confident you could solo on this or work through a problem alone. Can teach means you're willing to help others, right? So I think your tech lead, senior engineer, staff engineer, those people, we would hope to see that from them. And leveled up, this is where you think like as a result of what we did, your knowledge went up. And so you were seeing that with business knowledge, platform knowledge, and solution architecture. It's a qualitative measure. I'll admit that. It isn't something we can tie to P&L, but it is a measure saying we made some kind of progress in kind of leveling the skill or de-risking this in this case. Okay, so if we follow this through, kind of a similar thing. I won't drain this slide. We're kind of running short on time, but the core thing is the workflow is very much the same. We do some discovery. In this case, we use the skills matrix. I looked at their architecture diagrams. So that's kind of tough for me to understand. Can we recreate it? Would you humor me? We found an outcome where the team wants to understand the system well enough to make this change in a way that isn't scary or risky or hard or impossible. We use things like velocity and short cycle times to measure our progress on this. So we have incremental steps that are being made. We're not just going away as engineering for N months and being like, good luck product, right? We're kind of aligning it so product can actually participate in this and kind of roadmap on this, right? And then we're looking at the skills matrix afterwards and saying, did we measure? We're also looking at things like velocity and short cycle times. So, this was 6 weeks, right? This was a large refactoring kind of done and I not necessarily completed over 6 weeks, but significant progress made, like over half of it done in 6 weeks.
I think that's pretty incredible in 6 weeks. How many of these have we seen where we signed up for a quarter or maybe a half year and it went more than a year? To be able to get to something and validate something in 6 weeks is pretty awesome.
Yeah. So what? We'll start with engineering this time. I think it's part of opening awareness that this is part of the job. I think trying to bring tech and business closer together. That sense of productivity is a big thing. And, arguably, I think we, as a collective, this group dramatically de-risked this thing. It could have spun off into nowhere land and we turned it into a discrete thing that we could measure doneness and progress on that mission.
Yeah, and Dave, if I can go on a little mini rant, engineers, especially senior engineers who are leaders, if you're not willing to stop coding for 5 minutes to have a conversation, you're no leader in my book. One of my huge pet peeves is when an engineer tells me, I don't have time to come to a discovery meeting. I don't have time to be a part of design because I'm too busy coding. And the only time I'm valuable to the org is when I'm coding. That's BS, especially if you think you want to be a senior technical advisor in your organization. So teaching and learning are all part of our jobs. As we flip to the product side here, hey, we got to learn how our product works a little bit more. You should be curious. You should be hungry. Yeah, you shouldn't have to read every class and understand every function, but you should have a general idea. And being an active part of this conversation is a great way to get that. The more we understand, the more we can understand the trade-offs as we're making investment decisions. The more we won't be double talked by the technical team, or the more they won't feel the need to double talk us because they won't think we're an idiot. Last but not least, I think this was a really cheap way to upskill engineers or team members in general, not just engineers. Now, all of a sudden, instead of just having one or two people that know the platform, maybe we have a half dozen people that know the platform. That flexibility is a huge benefit to the team and the product down the road.
All right. So, common to both of these scenarios is another model that we're kind of using more and more. This emerged from practice, right? But when we look back on years of practice and, scores of these engagements, right, we kind of see a pattern emerge, right? We're kind of doing some discovery, understanding what's happening, building a option, right, for investment. It's kind of like an experiment in product, right? What outcome are we seeking in this option? Like, so what? What does this do for us? For whom, right? And identifying some metrics that let us know, are we making kind of progress toward that outcome? Some leading indicators, and then framing up an experiment. And then lastly, just kind of going around and, scrutinizing that option when we measure it. So we'll do some stuff, we'll look back at it and say, hey, did this move the needles in the way that we thought? Are they the right needles? Are they not moving? That kind of thing. Now, if this looks familiar, it's because it is, right? This is very much like the double diamond from design thinking. This is very much like what product people are kind of used to, where they explore a bunch of problems, right? And they converge on a problem to be solved. And then they'll explore a bunch of solutions and converge on a solution to be solved. So I think, what's good for the goose is good for the gander, and engineering can learn a lot by the way product operates, and probably vice versa. So breaking it down a little bit, the discovery loop, few tools we like. Surveys are a kind of good tool to more top-down kind of understand what's happening, or understand, are there pockets of issues? We really like the tool DevX 360. It's the best survey we've found. It's the best developer experience measurement tool we found. I've looked at, I would say all of them, but they keep cropping up. The biggest thing is, if you want to know what's holding people back, just ask them, right? There's also, discovery can be intuitional. It can be gut-based. You can ask people what's happening. They might be a little bit afraid to kind of answer you, but something like the skills matrix can help highlight that a little bit, right? And there's all kinds of fancy tools. There's log data, there's product analytics, there's things like Endepend, Sonar Cube, things like that that you can kind of use to do discovery.
Yeah, and I think listening is a big thing as we're trying to discover areas to invest in with respect to, technical investment. Listen to your engineers. One thing I always found as a product manager is there's usually one or two areas of the product they just don't want to go into. The estimates seem to come back really high. There's always a reason why that isn't the best next thing to do. Give the time to invest in the refactoring and you'll see that tune change really, really quickly. Also, listen to your customers. Where are they saying it's unstable? Where are they saying they don't trust the data? Where are we seeing customer reported bugs start to cluster? That likely is pointing to an opportunity as well.
Yeah, in terms of optionality, I think kind of answering the so what, and that may be a more meaningful for different audiences. What does the investment give you? I would say, if you're going to keep a backlog of things, I like maybe 2 or 3 as an upper boundary for that backlog and one in, one out. So if you decide, hey, we've discovered something else, what comes out as a trade-off? Let's not have a huge backlog of technical investment options. Those metrics are temporary usually, right? They're not things that are going to turn into KPIs. They're usually scaffolding metrics that kind of tell you, is this working? And lastly, you got to be prepared to sell these options, which is kind of a weird stance for engineers. I know sometimes, believe me, I know. It's awkward, but you do have to kind of say, what's the value prop?
Yeah, and please work with us on that. We're not the enemy. We all want the same thing. We want to make the product greater, but please understand, although it feels to you, all you have to do is sell to your product manager and get her to agree to it. It's not that simple, of course. We answer to someone as well. And often we're selling to the boardroom and the C-suite. So help us to sell. Help us to create a value-based argument and help us to define what the impact to the customer and the market are going to be. Because when we can show an ROI there, it's going to be really easy to get a yes back. But if we can't show an ROI there or we can't explain it in a way they will understand, we will most often get a no back.
Yeah. So few characteristics of good options. I'll leave this here as a sort of cheat sheet. You can grab this from the slides. I think the one I'd like to focus on is value clearly stated as outcomes, kind of riffing off what Ann said. I love this XKCD cartoon, which kind of says on the top, how often do you do a task, right? And how much time should you shave off? So one thing is always an option is to eliminate toil. That's good for development, and that, is an investment that speeds up product throughput, right? Or feature throughput, right? So if you kind of look at this and say, how often are you doing something and how much time could you shave off by automating it? If you're finding something where it's like 9 months, 8 weeks, something down here, that might be a worthwhile candidate. And it's not much of a leap to go down and start to build a little bit of a back of envelope math on ROI or cost of delay. So W is average hourly rate of engineers' total compensation. T is time it takes to do the toilsome activity in a given period of time. F is number of times you do it in a year. So you can multiply W times T times F to come up with the activity cost. And then say, how long is it going to take to kind of automate that thing? Right? So this isn't story points. This is time. This is money. These are real things. Depends which physicist you ask, but to me, they're real. Right? And you can kind of compute an ROI. And coming to people, thank you, you caught my joke. Coming to people with this, I think will get better results. So, just one way to think about it. You can't always do it. Sometimes you have to kind of, ballpark it or give an upper bound, lower bound. But if you can tie it to time and money, you have a pretty compelling argument.
Yeah, and when we need consensus from engineering management and we need consensus from the PMO, they get stuff like this.
Yes. So use what's dominant in the system to change it quickly. Jenny Holzer. All right. So how do we sell our product partners, Ann?
Yeah, I think the clear thing is, Think of it not as much as selling your product partners, but collaborating with your product partners to sell whoever's in control of the product strategy and the roadmap. And in most companies, that's more than one organization and more than one person. So first thing, please state the problem clearly and try not to throw FUD and technical language at it that is unnecessary. Yeah, okay, maybe you think we're stupid. Yeah, maybe we are. But let's talk in clear problems that we can all understand, because if we're stupid, we're gonna have to up level that another level of stupid. So please help us. Also, avoid we talked in the opening about how that term tech debt sucks. Let's not call it tech debt. Let's not call it refactoring. Let's say we have a problem in our product and let's go after it. Just like a missing feature, that's a problem that we have an opportunity to solve for a customer. This is no different. Sometimes people just hear tech debt or refactoring and they think engineering's just going off surfing TikTok or something. Okay, we all know that's not true, but let's fight through that perception because it is real work. Help us pose experiments. I'll say yes 100% of the time to something that would take one day, and I'll probably say no 100% of the time to something that would take a year. How can we do some small experimentation? How can you help us write some smaller checks? Then we start to show a return. We'll build trust. We'll be able to get bigger checks. And long story short, let's baseline that data, let's measure that data, and let's start to show an ROI. We'll build trust together, and in the future, we'll have to do less of this justifying, although we still should for our own edification, but we'll earn the trust of those above us, and all of us collectively will have more control over the product, its technical health, and the roadmap.
So a couple tips toward the loop around acting and measuring. A lot of the stories that we shared earlier were done collaboratively, right? So we were using this kind of ensemble software teaming approach, and we think that really elevates the learning, right? So when we all have that learning concurrently, can take care of some of the social issues with technical debt, which are sometimes quite profound. Um, if your measures don't move, you're either using the wrong metrics or your option isn't yielding the desired outcome. So the outcome might be off, the measurements might be off. This is a lot like product experimentation. You need to pay attention to those things. And reviewing progress regularly is really, I think, how you kind of stoke the fans of change, right, with this stuff. That's what we have prepared for you today. We do have a playbook that will be coming with the materials, the recording. Playbook is just kind of a way to organize your team around this approach. We do internal talks. You can have us come into your organization and we'll talk on this or some other topics. So check that link out. We do have a great partnership with this company, DX. Their DevX 360 survey kind of gives us some of those metrics that we can throw into this loop. And we do have a technical investment workshop if you'd like to go further with us. Other than that, find us on LinkedIn. Please connect with us. We'd love to kind of track your progress, and subscribe to our newsletter, which is where you will get this Miro board and the playbook. You don't have to subscribe. You just have to go to the newsletter. That's where it will be distributed. And yeah, thank you so much for your time and attention. We really appreciate you.